The following is the video solution from JSCT Solutions. Question 8, 8.1 says, in the diagram, O is the center of the circle. MNPR is a cyclic quadrilateral, and SN is a diameter of the circle. Then we have chord MS and radius OR are drawn, and we are told that angle M2 is equal to 64 degrees. The first question is to determine, given reasons, the size of the following angles. And the first angle we need to find is angle P. Now notice where angle P is. Angle P is at the circumference. And we know that this shape is a cyclic quad. Now we have the angle opposite angle P. What do we know about the opposite angles in a cyclic quad? They are supplementary, meaning they add up to 180 degrees. So angle P will be found by saying 180 degrees minus 64 degrees. And of course, we will put down our reason. And this is equal to 116 degrees. And that is our answer. Question 8.1.2 says we need to find the size of angle M1. So once we find an angle, it's best to put it down because it will probably help you with the next question. So this is 116 degrees. And now we need to find angle M1. So M1 is over here. It is at the circumference, and we could have been able to use O1, but O1 is not present. So we would need to use something else. It's at the circumference, but you notice that we have SN, which is a diameter, and this is part of the angle supported by the diameter at the circumference. So it means that these two, they should add up to 90 degrees. Because the angle in a semicircle is equal to 90 degrees. So we can simply tell them that angle M1 would be found by saying 90 degrees minus 64 degrees, and we'll give them the reason. And angle M1 is therefore equal to 26 degrees. And that is our answer, and we'll also fill it in the diagram. Question 8.1.3, we need to find the size of angle O1. Okay, so that has been filled down. And O1 is what we spoke about previously. So you see how this arc SR is supporting angle O1 at the center, but it's also at the same time supporting angle M1 at the circumference. So the angle at the center is twice the size of the angle at the circumference as long as they are supported by the same chord or arc. So angle O1 is double of 26 degrees. So we can tell them that angle O1 will simply be found by saying 2 times 26 degrees. And of course, we'll give them our reason. Okay, there we go. And so therefore, angle O1 is simply equal to 52 degrees. And that is our answer. Question 8.2 says, in the diagram, ABG is drawn. Then D and E are midpoints of AB and AG respectively. AG and BG are produced to C and H respectively, and then F is a point on BG such that FG is parallel to CH. Okay, so we've got these here, and the first question is we need to give reasons why DE is parallel to BH. Why are these two lines parallel? Well, looking at this diagram with this triangle over here, you can see that D is the midpoint of AB and E is the midpoint of AG. This is the midpoint theorem that we can use here. Okay, not the converse, the midpoint theorem. The midpoint theorem says that if AD is equal to DB and AE is equal to EG, then what we can conclude is that DE is first of all parallel to BG and that BG is equal to twice the size of DE. So the main reason they are parallel is because of the midpoint theorem. And that is our answer. Question 8.2.2 says, if it is further given that FC over BF is equal to 1 over 4, it's best to start putting that down. So FC over BF. FC takes 1 part, so we can call that A. BF takes 4 parts, so we can call that 4A. Okay, so that's what we have there. And then they say DE equals 3x minus 1. DE is 3x minus 1 and GH is x plus 1. So GH, this part, is x plus 1. And they want us to calculate, given reasons, x. Okay, so looking at this, to find x, we need an equation to be able to find x. And the best way to form an equation right now would be in this, because we actually know the ratios of this side. So for us to do that, because these lines are already parallel, we can find BG first. But here's the thing about BG. We know that BG is going to be twice the size of this. So we can actually tell them that. So let's find BG first. It will be in terms of x. But BG is twice the size of DE, which is equal to 3x minus 1. And it is twice the size because of the midpoint theorem. I think I said formula. It's supposed to be theorem. So BG in terms of x is equal to 2 times 3x minus 1. And so therefore BG is simply 6x minus 2. Okay, so now we have a value for BG. This is simply 6x minus 2. And here's where our equation comes. Because these lines are parallel, we can use the proportionality theorem on this. So we can go ahead and tell them BG over GH is equal to, and then we tell them what it's equal to. You can use it in this form as well. It's also fine. So yeah, let's just go like that. So we're looking at FC over BF. So we will take GH over BG. So it corresponds with FC over BF. So that would be equal to, because of the proportionality theorem, FC over BF. FC over BF. And we can either give the reason proportionality theorem or tell them it's because we have a line drawn parallel to one side of the triangle. But you would probably notice it's easier to just say prop theorem. So there we go. Okay, and now we can just fill in what they are. So GH is, like they told us, x plus 1. So in place of GH, we say x plus 1 over BG, we found to be 6x minus 2, is equal to FC over BF is simply just 1 over 4. So this is equal to 1 over 4. And now we can solve for x. So we can cross multiply straight away. So that is just going to be, let's multiply those two together first. So that's going to be 6x minus 2 is equal to, and if you say this times 4, remember this is one term, it must multiply with both terms. So times x is 4x times 1 is positive 4. Then transpose everything with x. So that's going to be 6x minus 4x, which is 2x, is equal to, and that is 4 plus 2, which is 6. And if you divide both hand sides by 2, x is therefore equal to 3. And that is our answer.